Hi everyone, welcome to a new video. In this video, we focus on two things. First, we prove the quadratic formula. And the second thing is that we'll try to understand why the discriminant determines the number of roots. As you know, the quantity b squared minus 4ac is called the discriminant, and based on its value, whether it's positive, 0, or negative, you will know whether you have two real roots or one real roots or no real roots. So we'll try to understand also in this video why is that the case. So let's start with the proof first. The proof in this video is based on completing the square. So if you are not familiar or you need to refresh your memory about solving quadratic equation by completing the square, then you can check another video on the channel that explain the method of completing the square. So then, assuming that you are familiar with completing the square, let's try to complete the square for the quadratic equation. So the first thing that we need to do is to make the leading coefficient 1. So we want to make the coefficient of x squared 1. And in this case, we'll divide by a. So divide both sides by a. Remember, a cannot be 0. So it's fine to divide by a. You may be wondering why a cannot be 0. Because if a is 0, this term will disappear. And if this disappears, then you will not have a quadratic equation. To have a quadratic equation, we need the x squared term. So a cannot be 0. And in that case, when you're dividing by a, you will get x squared term because the a will cancel with the a. The next term will be b divided by ax plus c divided by a equal to 0. Next step, let's move the constant term to the right hand side. So we'll get x squared plus b over ax equal to minus c divided by a. Now we come to the step where we need to complete the square. And to complete the square, we need to add a term. And that term is simply the square of half the coefficient of x. So the coefficient of x here is b over a. Half of that will be b over 2a. So actually we need to add the square of that. So we'll get x squared plus b over ax plus, now this is the term that we add to complete the square, b over 2a. This is half the coefficient of x and we square it, equal to minus c over a. Of course, to balance things out, we need to add also the same thing to the other side. So we'll get b over 2a squared. Now this term here is actually a perfect square and can be written as x plus b over 2a squared. If you expand this, again, you should get back this one. And in the other side, you will get minus c over a plus, if you square this quantity, you will get b squared over 4a squared. And then this is equal to, we can take the 4a squared as a common term. So then 4a squared divided by a, that give you 4a, and you multiply it with c, you'll get minus 4ac plus b squared. In other words, what we are getting here is x plus b over 2a squared equal to, let me rearrange the terms here, so get b squared minus 4ac over 4a squared. Now let's take the square root of both sides. So we'll get x plus b over 2a. And here, when we are taking the square root, we need to consider both the positive and negative. Because when you are squaring, the negative sign will also disappear. So that gives you a possible solution. And we discussed this in the video that talk about completing the square. You can refer back to that video. So then you get b squared minus 4ac divided by 4a squared. And then you can write this as plus minus the square root of b squared minus 4ac divided by the square root of 4a squared. Or this is equal to plus minus b squared minus 4ac. You take the square root of 4, that give you 2. You take the square root of a squared, that give you a. So what we are having so far is the following: x plus b over 2a equal to plus minus b squared minus 4ac divided by 2a. And then to get x, I can move b over 2a to the other side. So get minus b divided by 2a plus minus b squared minus 4ac divided by 2a. Or, because you can see here 2a is common for both, then you get minus b plus minus b squared minus 4ac. And this is the quadratic formula. So this completes the first part, which is the proof of the quadratic formula. So now let's look at why the discriminant determine the roots. And to do that, we need the following equation that we get when we are trying to drive quadratic formula. So let me rewrite that. We'll start with this equation. So this was part of the derivation. We find out that x plus b over 2a squared equal to b squared minus 4ac divided by 4a squared. Now let's understand this equation. If you look at the left-hand side, this one, this is squared. So it doesn't matter what you have inside. You have positive when you square it, you get positive. If you have negative when you square it, you get positive. If you have 0, you will get 0. So regardless of what is the value, the numerical value that you have inside the parentheses, once you square it, you will always have either positive or 0. In other words, the left-hand side cannot be negative. So this cannot be negative. Can be positive, can be 0, but not negative. We look at the right-hand side. If you look at this quantity here, 4a squared, this is always positive. If a is negative, when you square it, you get positive. And of course, if it is positive, you will get still positive. And remember, we say a cannot be 0. Because if a is 0, the x squared term disappears and you will not have a quadratic. So this cannot be 0. So this is always positive. What this means is that the sign for the right-hand side, whether it's a positive quantity or negative quantity, actually will be determined by this. b squared minus 4ac. So this determines the sign. Okay? So whether it's positive, negative, or 0. And this is actually what's called the discriminant. b squared minus 4ac is the discriminant. So now let's consider a few cases. If b squared minus 4ac is less than 0, it's a negative quantity. So then the right-hand side will be also negative, because you have a negative divided by positive give you negative. And what this means then, that the equation that we have will be something like this. Some negative number. So this equation is saying that we are looking for a number. When you square it, it gives you a negative number. As we said, the left-hand side cannot be negative. It doesn't matter what's the numerical value or the quantity in the parentheses, this cannot be negative. And the right-hand side, then you should find a negative number. So this is impossible, cannot find a real solution. So in this case, there is no real solution. Okay, so this is one case when the discriminant is less than 0. You're actually getting impossible situation. You're trying to square a number that should give you a negative. So we don't have any real number. Now we are excluding here complex numbers. We're just focusing on real numbers. So there is no real solution. If b squared minus 4ac equal to 0, then again, from the equation that we have above, what we'll have is something like this. This is equal to 0. So you are squaring something and give you 0. So that thing has to be 0. This is the only thing that gives us 0. So this is the only possibility, is that the thing in the parentheses should be also 0. In other words, x is minus b over 2a. So here we are getting only one solution. When the discriminant is 0, we are getting one solution. The final possibility for the discriminant, b squared minus 4ac, is positive. Then our equation becomes something like this. Some positive number, let's call it p. And then to solve a question like this, you take the square root, so get b over 2a, and then you need to take both sides, plus and minus. Why plus and minus? Again, because when you are squaring, the minus sign disappears, so you have also a valid solution. If a 3 is a solution, then also minus 3 is a solution, because when you square minus 3, that gives you 9, and when you square 3, give you 9. Both of them give you correct solution. So this will lead to two solutions. One will be coming from the equation when we are considering the positive case, and the second solution will get it when we are considering the negative case. So this was a simple explanation why the discriminant determine the number of roots. By the way, there is another video on the channel to prove the quadratic formula using another method called Gaussian law method. So if you are interested to see this alternative proof, you can check also the channel for that video. Thank you for watching. If you find this video useful, please give it a like and consider also subscribing to the channel and turn notification on so you get notified about new content. Thank you for watching.